So hello guys, today we are gonna solve another problem from CSES Problemset, and the problem which we'll be solving is message route. So in this problem we are given n computers and m connections, and our task is to reach from first computer to the nth computer and the minimum steps. So we can traverse through its neighbors only, and we have to try to minimize the number of steps which we require to reach till n. And if it is not possible to reach the end, we have to just print impossible. So let's look at example test case. Here we are given one edges from 1 to 2, 1 to 3, 1 to 4. So there is 1 over here and there is 3 edges connected to it, 2, 3 and 4. After that 2 and 3 is connected, and then at the last there is an edge from 4 to 5. So we can see 1, 4 and 5 is the one path which can lead from 1 to 5, and that's what the answer is. So we just have to implement it into the code as well. So let's try to write the code. First of all, we have to take n and m, that is number of nodes and number of edges. After that we can just directly create an adjacency list, because it is no point to create an edges vector and store all the edges over there, because it is not gonna help us at any time. So let's just try to take all the input, means we have to, there are m edges, so not n, m, and let's declare two variables a and b. So every time there will be two edges, and we can just say adjacency of a dot pushback of b, similarly adjacency of b dot pushback of a. That's cool. After that, what we need to do is we are going to use BFS algorithm, because to find the minimum number of steps to reach from one point to another, we usually try to use BFS only. So to do BFS, we would require a queue data structure, and after that we require an visited array, and initially all are marked with 0, means they are not visited. Also, to return the output, we would require to print and backtrack what was the previous node of any current node. So we can say that we would require a parent array as well, and initially let's say all has a parent of -1. So to start our BFS, the initial node which we are standing at is 1, so we can say visited of 1 equals to 1. Let's try to write the BFS. While queue is not empty, what you have to do is pop out the first element from the queue, that is current node is equals to queue dot front, after that queue dot pop, and now we have to traverse through its neighbors, adjacency of that current node, and if it isn't visited, so you can just push it into the queue and mark it as visited. Okay, and we also need to store the parent, so we can say parent of it equal to node, and at the end, if we reach to the last node, that is if our current node is same as the last node, that is n, we can just break out from the loop. So we can also use another variable, that is if we have reached the end, that is initially we haven't reached the end, and if we reach it, we can just update it, and here we can add another condition, that is till we reach the end you have to run the BFS algorithm. And if there is a case that we haven't reached end singular time, so we can just see out impossible. So let's just copy it from here, and if we reach the end, then we have to store the path. So let's call it vector of int path, and let's try to traverse it from the last element. We can say that if current is not equals to 1, what we can do is path dot push back current element, and our current will be updated to current parent of current, right? And if we reach to the 1 will not get stored into the path, so we can just write store 1 over here as well, and the path would be 541, but we want the answer as 145, so we can just reverse it, reverse path dot begin and path dot end, and let's try to print the path. First of all, we need to store the print the size, and after that we can just store the path, means print the path, cout of it. Nice. Let's try to run the code over here. Let's see. Yes, it's completely fine. Let's also try to submit the code. Okay, run it over here. If we are making any mistakes, then okay, 3145 is the correct answer, which was expected. Let's try to submit it. This is the problem, and let's try to see if we have solved the correct. Yes, it is accepted. So that's how we are going to solve the problem. Thank you so much for watching. Bye bye.